Hi, I think it may have been a little confusing with the assignments this week because the morning classes are doing something different from the afternoon. So we're going to have to get used to that. So I'm changing the way that I write it on Canvas and put it in announcements. And then you can go to the module, and between the three of those places, you can decide whether you need to stay on Canvas and do a discussion or an assignment there, or whether you need to go to OneNote. All right? Now, we had a discussion over whether to drink tap water or not to drink tap water, and I hope most of you completed it. Here was the variety of responses that I saw. Well, what makes it good to drink tap water? Well, it's easy to get from the tap and you can drink as much as you want, right? You're not limited to the expensive bottled water. And people considered it okay, safe. Someone else said, well, it is checked more often. That is, the quality of our Mesa tap water is tested. I don't know if most of you knew this, but this person did. It tastes okay. And lot of people mentioned it doesn't require plastic bottles because the disposal of all those plastic bottles is not good for the environment. And so that disturbed them enough that they only drank tap water unless, you know, all they could get was bottled. And then I can't tell the difference. When I drink tap water and bottled water, this person said, I can't tell the difference in taste. In contrast, the con was it tastes awful. They don't like the taste of tap water was the pervading reason why they don't drink it. Secondly, they don't think it's safe enough. And the key to that was the idea you don't know what's in it. Sometimes when it comes out of the tap, it looks white. I think that this person's referring to the bubbles that are in it, that come out at first, and it looks unusual. And of course, it's less convenient to carry around. We don't always have water bottles with us. All right. And then quite a few people mentioned that in a TV show, they said tap water wasn't good for you. And one person even named the TV show. All right. That they saw that. All right. So the issue is, may I now comment on some of the things you said? The TV show one, let's go there first. When we talk generally in the United States about tap water, it varies considerably from place to place. So, of all the things that we eat or drink, tap water is the one that is most local. It depends on where we get our water. So, we don't get tap water from a faraway source, we get tap water from the nearest by source. All right. So that means that a TV show on tap water in general across the United States can only be very, very general. And it doesn't say anything about the tap water that you would drink from your faucet. All right. But it is true that people are concerned about water quality. That's what it's called, the quality of water, because um, that's the most precious resource we have. Humans cannot exist without water. All right, so that's why it is so important that you know your tap water is safe because we drink so much of it, and babies drink tap water, children drink tap water, those with smaller bodies, so things are um, are more harmful to smaller people than they are to larger people. Okay, now the taste. I'm wondering if I would like to say it could be that you're somewhat biased about the quality of tap water because it doesn't taste as good to you as bottled water. All right, and I would like to mention what bottled water is. Bottled water is tap water from some other place in the United States where they're known for having tastier water. So it's tap water from somewhere that gets its water from sources that taste really good. For example, my parents both were from Denver. So when we would go there from Texas when I was a kid and drink their water, it tasted really good. And for one thing, it was a lot colder than the water in Texas. Just like here in Arizona, our tap water is very warm during the summer. And so cool, cold water tastes much better to us. All right. When we go other places to drink water. So we know there are differences in water quality from place to place. All right. So the taste of it could bias us and make us think, well, there's something in there that's making it taste awful, and whatever that is not good for us. But we don't really know that. All right. So let's go over here then to what this assignment was about. Now, this assignment looked hairy. All right, I admit it. It looked kind of hairy. But, but, that isn't going to keep you from drinking it, is it? Excuse me, from doing it. I'm sorry, I got distracted for a moment. I'm trying to make this bigger. All right, so the amount of chemical found in tap water is measured in these ways: parts per million, ppm, parts per billion, ppb, or parts per trillion, ppt. This is the chemical's concentration in the water. And the table below shows what these amounts mean. All right, so parts of chemical per parts of water. So the part of chemical per a million parts of water is what this first one means. So ppm, parts per million. What that means, 1 part per million, means there's 1 milligram of the chemical in 1 liter of water. A liter is about a quart. All right, so picture a quart of water, and if there was 1 milligram found in that, that would be considered a concentration. The amount is called concentration of 1 part per million. However, 1 part per billion is much, much less, 1,000 times less. It's 1 milligram measured in 1,000 liters of water. So it means there's 1,000 as much of this chemical, part per billion. Part per trillion is a super tiny amount. 1 milligram, 1 part per trillion, if that was the concentration, would mean that 1 milligram would be found in 1 million liters of water. So the more dangerous a chemical is, the less we're allowed to have in our water. All right, so let's go down and look. So what I did was take the water report, and then I wrote all over it. So I got this off the internet. Let me pull this up a little. All right, and let me see if I can fix this. It looks a little crumbled there. Now let me get Mesa water quality. See if we can make it up. There we go. Okay, so how do we know how to figure out what something is safe? Well, then we're going to look at this. So I'm going to make this gigantic, and we're going to look right over here and hope it's within. Yep. Okay. Now, arsenic is dangerous. Probably you know that arsenic is a poison that used to be used in mystery stories all the time. Well, arsenic is dangerous enough that it's measured in parts per billion. That is, we can only find 1 milligram of that in 1,000 liters of water. All right, now, right here, this second column, this column right after the units, is the one that tells us how much we're allowed to have in drinking water. 10 parts per billion is all we're allowed to have. Now you say, but why do we have any at all? Well, because did you know that in Arizona we have a lot of rocks? that have arsenic in them. And so when it rains and rocks are dissolved, or when it rains and water goes through the ground all the way down into wells, where we also get our water, well, some of that arsenic is dissolved and gets into our water. So 10 parts per billion, though, is what we're allowed to have because we can't get rid of it all. Now, ideally, we wouldn't have very much, but this is considered a safe amount to ingest on a regular basis. All right, now barium, chromium. I want to go down to chromium because chromium, parts per billion, that's something we also in our local area have a lot of. All right, so this says we are allowed to have 100 parts per billion. Very tiny, only 1 milligram in 1,000 liters of water are we allowed to have. But that's considered to be a safe amount for us to ingest on a regular basis. All right, fluoride, naturally occurring, not added to the water for our teeth, parts per million. So we're allowed to have quite a bit more, 1,000 times more of this. And for naturally occurring, we don't want to have more than 4, all right, because 4 doesn't hurt you. I knew a student once from in Texas who the area he lived in had a lot of fluoride in the rocks, more than 4. I mean, much more than 4. And it causes spotted teeth. So when there's too high fluoride, I don't know if it does other damage to you, but your teeth are strong and healthy, but they have brown spots on them. All right, so that's why we don't want to have too much fluoride, even though it's used to prevent cavities in places that don't have any naturally occurring. Nitrates come from fertilizers. So when water is washed off the fields, in the spring rains especially, nitrate gets into river water, and that's where it is primarily, but it also soaks through the ground into groundwater. All right, nickel, selenium, let's not talk about. Now, these guys are organic chemicals, and they are much more dangerous to us. So notice, of this first guy, dibromochloroPropane, we can only have a part per trillion. Oh my gosh. That is 1 milligram in 1,000,000 liters of water. All right? Because we're not supposed to have any. All right, all of these we shouldn't have any of. 5 parts per billion trichloroethane. It's allowed a higher concentration, probably, but it's less toxic to us. And part per billion, the same thing with tetrachloroethylene. All right, so we shouldn't have very much at all. And then let's go down to this is radioactive stuff. All right. There's always going to be a little radioactivity in the environment because it actually comes from outer space. But whenever you have uranium rocks, you also would have some radioactive particles. We're allowed to have parts per billion amounts, 1 milligram per 1,000 liters. So we're allowed to have 30, although all of this we would prefer to get nothing. But if you're alive, you're getting radiation. Okay. Radium is a radioactive element. We're allowed to have, this is a different unit, so we'll skip it, but it's a radioactive unit. All right? Now, the last thing I want to talk to you about is turbidity. Turbidity means the water is not transparent. So if you hold it up, light doesn't go through it as well as it does a transparent solution. And the other thing is it may be highly colored as well. When you've probably seen iron come out of faucets before when the faucet hasn't been turned on for a long time. All right. So water should be totally clear and transparent, right? Colorless. All right. So turbidity is important. It's the color and transparency of the water. All right. And I don't know what the NTU unit is. I should have looked it up before. It's down, it's on the sheet of definitions. All right, so we can't have any higher than 1. All right, knowing that then, Here's the key. What you do is go, let me get over to the right part. All right, what you're going to do is put the allowed amount, which we just went over, all right, for arsenic, chromium, nitrates, organic chemicals, radioactive isotopes, all right, and turbidity as well, all right? I want you to do that right now. Go. Turn off this video and do this now. You'll have to do this yourself because I'm not going to go over it. So do that now, please. Okay, now that you finished that, we're going to go look at the other part of this. Once you see this, you'll think, oh, this wasn't nearly as hard to figure out as I thought it was. All right? So we're going to now look at this part. I found this very interesting. I hope you did too. All right. I hope you did too. Let me get it so that we get our water from 4 different places. It's blended together to be tap water. That's really a healthy way to do it because if it turns out that one river is higher in something than another, then you would be diluting it with other water. So where do we get it? Well, 2 sources. We get the city's own Val Vista water is from a river, and the eastern and southern zone water is from rivers. City's own wells are groundwater, that is, you have to dig to get the water at a certain depth. Eastern zone wells are also groundwater. All right, that's water that's stored under the earth that has gone through the soil and been filtered and gone down into a reservoir way underneath ground. So you can tap into those areas where water is sandwiched between layers of the earth. Okay, so this city zone, Val Vista, this comes from the Salt River and the Verde Rivers. All right? And this eastern and southern zones of Mesa tap water come from the Central Arizona Project, and that's the Colorado River. All right, so we have 3 rivers that are involved, and then city dug wells. All right, so we see that half of our water comes from this Colorado River, and a third of our water comes from the Salt River, and Verde Rivers. And then the city wells account for about 10% of our water. Now, what I'm going to want you to do in this one, all right, what I want you to do is look at these amounts. So there was none detected in the Val Vista water for this first thing. And let's go over to remind ourselves, this first thing was arsenic. All right, so arsenic, all right, we were allowed to have 10 parts per billion. How many did we have in the water? Well, the average here, 4.5, none in the Val Vista zone, 2.1 in the eastern and southern zones, and 5 in the wells in the east. 10 was allowed. So let's just do a simple average of 4.5, nothing, 4.5, 2.1, and 5. And we could say it seems that 3 to 4 would be about the number of parts per billion. Let's go back. All right, parts per billion. So we have 3 to 4 parts per billion of arsenic. 3 to 4 is what you would put there. Arsenic, 3 to 4. We were allowed to have 10, you had here. Is this water then acceptable to drink? Put yes or no. Since 4 is less than 10, the water is acceptable to drink. All right, now I've given you one example, and I'm expecting you to go through and look at chromium, nitrates, the organic chemicals, just average them all, and radioactive isotopes, and then finally turbidity. All right, how clear the water is. I want you to now do the same thing with those. So do that now, and I expect you to be able to think that clearly. All right, talk to you later. Bye.